This topic is way too cool for one video, so you better tune in for part 2.
Cool school comment clip time!
Today we're going to talk about light and all the really cool things that it can do. Light is a form of energy that we can see, and it travels in waves.
It has a lot of really cool properties, like it can be absorbed into things, making them feel hot when you touch them. This is called absorption. It can also bounce off of objects like mirrors, and that's called reflection. And then there's refraction, where light waves bend, and that's why your straw looks all broken up when you put it in water.
Let's go back to the idea of light traveling in waves. Now, if you were to aim this flashlight at a wall and turn it on, the light would appear on the other side instantaneously, right? Right, but what really happens is that wave of light leaves the flashlight and journeys across the room to the wall. It just happens so quickly, you don't see it.
We call this the speed of light, and it's traveling at a speed of 300 million meters per second.
It is the fastest speed in the universe. Nothing comes close. It's pretty cool. This is part 2, so if you haven't already, take a minute to watch part 1.
Cool school comment clip time!
So we've already learned that light is energy that we can see and that it travels really, really fast. Now we're going to focus our attention to the skies and talk about something that we really can't live without, stars. Not these kind of stars.
I'm talking about the 200 billion trillion giant spheres of burning gas scattered all over the universe.
We're going to start with a star you should all be familiar with, a main sequence star called the Sun.
Located at the center of our solar system, the Sun has no land or rock. It's all gas, mostly made of hydrogen and helium. The Sun is over 100 times bigger than the Earth, but it's definitely not the biggest star out there.
Remember when I said that even though it's too fast for us to see, a light wave actually has to leave a flashlight and travel across the room? This is where it gets really cool.
Just like that flashlight, the light waves leave the Sun and travel through space to get to the Earth, but it takes them 8 minutes to get there. The Sun is just that far away.
Did you catch that? This means that if the Sun were to just vanish out of the blue, we wouldn't even know it vanished for 8 minutes. Now that we have a foundation, let's build on this concept.
Cool school comment clip time!
Remember, light travels really, really fast.
I'm talking 186,000 miles in 1 second, 300,000 kilometers in 1 second, and 7 times around the globe in 1 second fast.
Light can travel almost 6 trillion miles in 1 year. That's almost 9.5 trillion kilometers in 1 year.
Keeping that in mind, let's take a look at the second closest star to the Sun, a small low-mass star that is so dim it cannot be viewed with the naked eye. It's called Proxima Centauri.
Even though this star is relatively close, it still takes light waves over 4 years to reach the Earth. That's because Proxima Centauri is over 24 trillion miles away.
But instead of writing out all these really giant numbers, scientists use a measurement called light years.
A light year is the distance light travels in 1 year. For example, Proxima Centauri, where it takes over 4 years for light to get to Earth, is over 4 light years away.
If that star were to just disappear, it would take over 4 years for us to even realize it happened.
It's almost like you're looking back in time. Now that we have a solid understanding of the properties of light, the speed of light, and light years,
cool school comment clip time!
it's time for something really cool.
Depending on where you are located on the planet, at certain points in the year, you can look up at the night sky and see a well-known constellation called Orion.
Located in the shoulder of this constellation is a giant star called Beetlejuice.
And when I say giant, I mean really giant. Betelgeuse is a red supergiant star, and it is over 700 times bigger than our Sun.
This star is huge. If you were to put it in the middle of our solar system, it would stretch all the way past Jupiter. Betelgeuse is over 600 light years away, which means once again that it takes a light wave over 600 years to leave that star and reach our eyeballs.
In 2019, people began to observe that Betelgeuse looked a little bit dimmer than normal. Scientists realized that this was a result of a massive explosion.
And the dust and debris from that explosion was clouding our view of Betelgeuse. We were observing the dimness in 2019, but when did that explosion actually occur? That explosion occurred over 600 years ago. It just took that long for the blocked light waves to reach our eyes. It's so cool. We were literally looking back in time.